So I want to thank Taylor and the Oracle team for inviting Intel to come today and share our perspectives on HPC and cloud, on the market, some of our strategy, and a little bit about how we team together. I'm not going to get into a lot on Intel products today. That's not where my focus is. We're instead going to talk about, again, our strategy. So my role is a chief technologist for Intel for HPC, but I also lead our HPC cloud efforts and tend to focus on emerging trends in the industry and getting our strategies in place and our programs in place. So as part of that, if you've ever been to a Bill Magro talk before, and I know several of you in the room have, I always talk about the big trends in HPC that are underway today. One of them is that it's really expanding in its scale in terms of going to exascale. We're not going to talk about that today, but that's a big trend. Another one is the scope of workloads. We have heard about that today. That HPC, it's not just simulation and modeling anymore. We've got analytics, we've got AI. And finally, the big trend, and the reason we're all here today is the delivery. HPC is not all about delivering workload capability on-premise with dedicated supercomputers. It never has been only about that, or at least not for a very long time. But cloud is really changing things in the way people think about what the way HPC is delivered, and really changing the types of things you can do. So from an Intel perspective, we look at the Hyperion data, for example, where we talk about just a couple years ago, it's $26 billion of annual spending in HPC on about an 11% CAGR to $44 billion by 2022. The projection that goes alongside that is about $5.5 billion of cloud spending. So it's interesting to think about why people are looking at cloud. What are the barriers? We've heard a lot today about the different industries, how they're being overcome. Intel's interest, as you can imagine, is we'd love to see our business grow and grow with our partners. And from our perspective, cloud is going to be a driver of net growth for the industry, HPC overall. It is not about shifting spending. There's new capabilities, new opportunities, and as companies have access to high-performance computing, they tend to do more and they consume more. So our strategies are very much focused on removing friction and allowing the ecosystem that's developed on-prem to thrive in the cloud, and as a result, help people get access to the HPC they want and need. And in the end, we all win. So the big drivers of HPC in the cloud that we see are really these four. There's a long list if you go look at the survey data. But the number one is demand surges. And we saw this in Teja's talk just a moment ago. If you provision for peak capacity, you're underutilized, you're wasting money. If you provision below peak demand, you can stay 100% utilized, but you have an opportunity cost. Engineers or whoever it is who's the consumer, scientists, are sitting not being as productive as they can, and humans are the most precious capital that any organization has. So how do we use cloud to augment the on-prem capabilities and unlock the capabilities and productivity of those people, resulting in better products, faster to market, quicker time to insight, quicker time to discovery if you're a scientist, more confidence in the results if you simply, by running more scenarios and understanding the sensitivity to varying inputs. There's so many ways that we can actually get better business or scientific engineering results by using cloud. R&D collaboration. The cloud providers like Oracle have the best worldwide networks, and teams are no longer centralized. Getting people together into a place where they can exchange information, look at common data, the cloud is ideal for that. That's another top reason. Scale on demand. This isn't just about augmenting your on-premise stuff. Oh, I'm busy and I've got a queue. This is about, I realize that I'm running one of those workloads in that 2x2 that maybe is not data intensive and maybe doesn't require a lot of tight coupling and communication. It's an embarrassingly parallel workload. But what happens if now, instead of sticking that in the queue, I could just have access to 500,000 cores for an hour? I can now have my time to insight, my time to a decision, even if it's narrowing a design space in manufacturing, all of a sudden can be dramatically shortened. So access to scale and solving problems that people just haven't even thought about before, we're starting to see that happen with cloud. And then finally, access new technologies. Whenever you go through the traditional buying process, you're making a commitment to something that's going to have a 3 or 4 year life on the floor. Having access to different technologies, the ones you didn't choose to serve workloads that perhaps are underserved, or to try out a new technology before you make the decision to put it into production. Cloud is great for that. So the diversity of offerings that are out there. So as a result, there's a lot of reasons that people are looking to the cloud, and we see this driving not only increased usage among existing HPC users, but it's enabling new industries where people will never build a data center. Tejas called out EDA. That's a prime example. The whole ecosystem to build chips has gotten so robust. It's so easy now to do silicon that people are actually doing EDA in the cloud exclusively. New startups. And you can go out and look at case studies of companies who are doing this. So there's tremendous new users who are going to come in through workstation only. I think you'll hear about this from Piyush at Altair. We've partnered for a long time. It's a tremendous opportunity of workstation only users whose productivity is constrained. Cloud can unlock that, and making it simple and removing the friction is what it's all about. So we got a deep dive in the last talk about the different industries, but this is my very simplistic one. You know, there's two dimensions here. One is a technical dimension, right to left. How hard is that workload, and can you run it in the cloud? And the vertical one is more about the trust and the comfort with putting your data in the cloud. A third dimension might be the data intensity, which is what Tejas used and talked about, you know, how much data do you have to move, because that impacts where your jobs run. But the point of this is different industries like FSI and genomics, without really having the technical requirements, you know, loose coupling, embarrassingly parallel, maybe not having huge data requirements or sensitivity to certain data. We're really early adopters in the cloud. Manufacturing sits on that edge. Some manufacturing workloads can run really well in the cloud because they're design studies. Others that require tremendous scaling maybe are beyond the reach of public cloud. And as Taylor showed you today, a lot of the focus with Oracle is driving that boundary, that frontier to the right, and expanding the scope of workloads that can run in public cloud. And as Tejas pointed out, there's certain people, even if you gave it to them free, they still wouldn't put their workload in the cloud. That's the vertical dimension. But it's a frontier, and these things are changing. So there's a lot of things that are happening. Let's talk about the technical dimension first. High performance instance types, we've talked about that a lot today. The Intel Xeon scalable processors that are available in the Oracle Cloud. The idea of allowing people to place things close together and manage that, you heard about that in the last talk, that it can improve in performance. High performance fabrics like the RDMA capability and bare metal instances. All of these are technologies that traditionally did not exist in cloud and are now there and are really pushing this boundary to the right. You saw the performance data that Taylor showed you. The scalability of these workloads really is converging with what you can see on-prem because of the fact that it's bare metal. The security certifications that exist in the cloud are giving people more and more comfort, and we're finding, and we're seeing this reflected in survey data, that people are getting comfortable that their data is safe in the cloud. In fact, we're starting to hear from some customers that they feel their data will be safer in the cloud than on-prem as they look at the stories of data breaches that are occurring in companies that are much larger than themselves and who they thought never could have been breached. And then finally, in the middle, critically important is things like batch interfaces and HPC orchestration. We had the discussion earlier about infrastructure, and I think Addison, you asked the question, you know, what do we mean by ecosystem? Because if you're running bare metal with a copy of Linux, don't you have access to everything? And in a sense, you do, but there's still a technical gap and an expertise gap from a traditional HPC user or administrator who's familiar with bringing boxes in, configuring them, setting up a software environment once, using whatever tools they've got, and then putting that into production. And in the cloud, you've got to be able to spin that up and tear it out down on demand, which means bringing cloud technologies to solve HPC configuration problems. And that's where HPC PaaS orchestration comes in. And Taylor mentioned some of the capabilities Oracle Cloud has. The batch interfaces you're going to hear a lot from Piyush about, I'm sure. But at the end of the day, HPC users are not administrators. They interface with HPC through binaries and through job scripts. And so bridging the gap and making them comfortable with HPC in the cloud is all about coming to them and bringing things on their terms, which means the binary works without modification, and their job scripts and their workflows can be accommodated. And so that's where a lot of energy is going on in the industry today to remove friction. So Taylor talked about this, but I think it's really critically important. A lot of the work in cloud over the last decade has been about cloud provides new ways to program, new ways to create cloud-native apps. But when you talk to the HPC community and when you talk to ISVs and HPC, by and large, they're not interested in re-architecting or rewriting their apps. What they're interested in is running their apps and running their workloads. So Intel has been promoting the notion of standard clusters for a long time. And I think we do have, as an industry, sort of a de facto cluster architecture that works. And the ISVs have confidence that they can ship a binary and have it run broadly regardless of vendor. We need to recreate that same ecosystem in the cloud. which is why I was so happy to see the growing ecosystem that Taylor showed. But it all comes down to creating that provisioning layer that bridges the underlying infrastructure and automation and security of cloud back to what the apps expect, which is they want to stand up and they want to run with no changes. And when you talk to the software vendors about that, they say, if you can give that to us, then we can be comfortable putting our apps in the cloud and start to grow our business without having to re-architect without return. So that's a big focus of Intel's engagement around cloud, is really on all these points and starting to remove that friction. I know you think of us in terms of CPUs, but this is the path to unlocking consumption. And the way we're rewarded, of course, is through our core business as a result of that consumption. So I want to say a little bit about Intel's and Oracle's partnership. We've been partners for, believe it or not, almost 25 years. So in the early days, of course, Oracle started as a database company, and Intel was a chip company who wanted to get into servers. And we worked very closely with Oracle in those early days to ensure that Oracle was ported to and ran well on Intel CPUs. That partnership has grown over the years, and now we work at every level in the stack. We work down at the system level, sharing roadmaps, as you heard, sometimes on a weekly cadence, and getting feedback, which influences our architecture, leads to new instructions, new capabilities in the CPU, or other components in the system. We collaborate at the system design level. For example, we've collaborated with Oracle around open fabrics and enabling the RDMA capabilities that are necessary for the scaling of the Oracle databases, distributed databases 10 years ago, and more recently for HPC applications. At the compiler and tool level, we work together to ensure that our compilers can extract the best performance on Oracle software, so you're getting the highest performance out, and that they're compatible with the Oracle Cloud. And then up into Linux, Oracle Linux, and so on. This is a place where Intel is very deeply engaged in the Linux community. We work very closely with Oracle to ensure that we're getting the best performance end to end. And this continues all the way up through the middleware and the other Oracle products. So we're delighted that the Oracle Cloud runs with Intel Xeon scalable processors and Intel SSDs in that cloud, and we look forward to continued collaboration with Tyler and team.